Our next speaker is Mr. Paul Tsui. Paul is the managing director of Esri China Limited. Esri is the world leader of geographic information system and mapping software. And prior to joining Esri, Paul has worked in Audit and Survey, the national mapping agency of the UK. And Paul has been appointed as the chairman of the Department of Geography Advisory Committee of the Hong Kong Baptist University since 2013. Paul is a member of the Royal Institution of Chartered Surveyors, a member of the Hong Kong Institute of Surveyors, and a registered professional surveyor in Hong Kong. Paul has also won the 1998 Best Paper Award held by the International Association of Chinese Professionals in GIS. So let's welcome our next speaker.
Ladies and gentlemen, first of all, I ask you to forgive my sexy voice because I have some recent problem with my vocal cord. Talking too much. Okay. First of all, to my surprise, this is my first instance to see there are so many speakers talking about spatial data in an event organized by Computer Science Department. Yeah. So it shows that spatial data is really important in AI and big data, right? Okay, today's I'm not going to the very complicated algorithm like Dr. Mobel and Dr. Kim in the previous talk. Instead, I'm going to introduce you how GIS technologies and AI can integrate with each other to deliver some very useful applications in the context of smart city. I think you are not strange to these three buzzwords: IoT, big data, AI, when you talk about smart city. But many people have ignored the GIS technology. Actually, GIS plays a very important role in smart city. Actually, GIS can connect all these three technologies. Why? First of all, the IoT. You know IoT, what is IoT, right? All the devices and things are connected and to the internet, right? And by 2020, there will be more than 50 billion things connected to the internet. But have you thought about, actually, Internet of Things has been generating a lot of data with locations. With the IoT, you have the big data, right? Can you imagine how much data can be generated within a minute in today's world? Just from the social media platform, you can see how much data is generated in 60 seconds in GeoAI. The data growth, the research expected there will be 40% annual growth and reach 44 GB by 2020. Where does the big data come from? It comes from the social media, mobile devices, your wearable device, smartphones, and sensors and smart tools. What can be there? The big data? It can be your activity data, how many steps you have walked, your post or your conversation in your social media apps, or the data from the sensor IoT device, and other real-time data. According to some research, 80% of our data has spatial component. Okay, like Dr. Kim said, the LiDAR data actually is the 3D point cloud. GPS, actually the most common IoT sensor, I think, is the GPS receiver in your mobile phone. It not only logs your location, but it also helps you to tag all your activity in your phone. Actually, have you thought about? Actually, big data can also be used to generate another big data. Actually, one of our partners, TomTom, they have agreement with Apple they can get all the GPS location from all iOS devices and Uber apps. And they use 500 million GPS devices, the data from the world, over the world, they use to calculate, to derive the real-time traffic information of every road in the world. Okay, you have the big data ready, okay? But how can you make it useful? You have to unlock it and open it. So we are all talking about open geospatial data. Open data has been always the top hottest topic in smart city. The advantage of open data can benefit the individual, startup, business, government, and globally. Actually, according to some research, geographic information has been recognized as the open data with the highest commercial value because it doesn't only, you can use it as it's alone. It also helps you to increase the value of other open data like social information, economic and business information. So our company has also set up this open geospatial data platform. We process about 130 data sets from the open data of government Hong Kong with location component and make it more useful form for our user in, say, API format. So our user can easily use our software to just type in the API and use the data and no need to pre-process it. But at city scale or country scale, if you want to do open geospatial data, you have to have a because spatial data infrastructure, right? To support, to share the open geospatial data to all the citizens and all the business. Actually, the Hong Kong government has committed to launch the CSDI, the Spatial Data Infrastructure Platform for Hong Kong in 2022. Okay, come to the GIS. GIS is the computer system to store, to capture, to analyze, and to visualize all the spatial and non-spatial related information. How can you use this data in smart city? First of all, you can use the open geospatial data to help to do business analysis and location intelligence to improve your profit and to improve to make your business operation more efficient. We always say smart cities start with smart planning. So GIS and geospatial data is also very useful in help the urban planning and urban design to make the city more smarter. It also, the GIS platform can now has been evolved to 3D GIS and model the whole city. Again, traffic has been the also hottest topic in smart city. So GIS is also very important in transportation planning and traffic management. A smart city must be a well-run city, right? And also a resilient city. So GIS is also help a lot in engineering and public work as well. So after you have got the result from your analytical result from your big data, you have to present it and to let other people know. This is a very popular way now to use operation dashboard. Actually, this dashboard is not just a normal dashboard. This is a map-sensitive and location-aware dashboard. That means when you move the map, the view, all the data reflect the data from that portion of the map already. Yeah. This is the real case in Japan. We help the government to use this dashboard to deliver a consistent and real-time accurate information for the Kumamoto earthquake in 2016. So that all the rescue crew, all the citizens can know what is the situation of the earthquake and the disaster recovery situation now. Another new development of this dashboard is that when it can be also auto-focusing dashboard. When the dashboard know, oh, there's an event happening in a certain place, it will automatically zoom into that place and let you know. Okay. This is a few dashboards we have created for Hong Kong and using the open data. Okay, we have IoT creating the big data. Now we need to use AI to analyze those big data to derive more meaningful results. Yeah, AI. Many people has arbitrarily used this term, okay, interchangeably, but actually they have a little bit different meaning, right? Okay, what's GeoAI? Geospatial and AI, okay? Actually, this is a example in Kuwait. They use geodata and AI to predict traffic condition without presence of many existing data for them to do the prediction. This is another case we use GIS and AI together to help the investor to find the best location to open a new restaurant by teaching the machine to learn where the restaurant has a good business, where the restaurant has bad business. Okay, next I let you watch a short video. This video will tell you how to use GIS and AI algorithm to do a very interesting application on taxation.
We'd like to share with you a couple of local government workflows that benefit from ArcGIS infused with AI. Let's take an example of automatically detecting swimming pools in a county so we can recommend updates to the tax assessment rate. Highlighted in blue here are residential parcels that are being assessed for having a pool. But as you can see, some of the parcels with pools are missing. The data is outdated. So can we use deep learning and solve this problem? Sure we can. Let me show you how. The first thing that deep learning needs is labeled data, training samples to learn from. I'm going to use the nape layer from the Living Atlas that has an infrared band and allows us to train a more accurate model. It's easy to label a few sample pools. And I'm going to use this included geoprocessing tool to export training samples from those labeled pools. This is what those samples look like. Now we are ready to train our model. And I'll do that in Jupyter Notebook, where I've imported the ArcGIS API for Python, and we are integrating it with deep learning libraries like PyTorch and FastAI. We'll use the training samples we just saw and train an object detection model. And looking at the results, see how beautifully the model has figured out where the pools are in these image chips. Now we are ready to deploy it, find all pools in the city. And that's where you see the true power of combining ArcGIS with AI. Now since I'm only interested in finding pools in residential areas, I'll bring in the zoning layer. And here's the code to deploy the model, find all pools in the city. But it isn't just about finding where the pools are. We need to join them with the parcels. The analysis tools in ArcGIS Online let me do just that. Let's look at the results and see how we are getting near perfect results, detections of all of these swimming pools. And the ones highlighted in red are the parcels that are not on the assessment road. Now I've done it for the entire city. This is what it looks like. We can take this data and generate a report of which parcels need to be then field verified. Another use of deep learning is for mosquito control agencies to find where the neglected pools are. Let's have a look at a few of them. Let's give it a moment. Let me try going to the other browser where I have this. Now we see how some of these could be breeding grounds for mosquitoes and insects. This one, for instance, is in a foreclosed property. And city government agencies can use this information and do mosquito abatement. That's how you take deep learning from the notebook and out into the field and solve real-world problems. Thank you.
Is it cool? For you computer work guy, you just type a line of code, you can see a beautiful map as your result, right? Actually, this example shows you how GIS, actually, do you know what's the most difficult part of AI? Using AI. Actually, AI algorithm, tons of AI algorithm has been developed 30 years ago, but nobody uses it. But the most difficult part using AI is the making of the training, preparation of the training data. So you can see the GIS let you very easily to prepare the training data, especially with the satellite imagery. Okay, and also one AI application can serve two purposes. One, to help government to increase their tax revenue, and the second is to help to control the dengue fever disease, right? Because we can teach the machine to recognize where are the living pools, where are the abandoned pools, because they are usually different in color. This is another example. We program a drone to fly over a car park every hour in a day. Okay? And then we use GIS to make a photo map with these drone images, and then we teach the machine to learn whether a parking lot is occupied or not, and also teach, if it's occupied, and also teach the machine what is the type of the car in the parking lot. Okay, you can see the schematic workflow and how it works. Okay, and then we can use a dashboard again to present the results, okay, and also to predict the occupancy rate of that car park in the coming hours or coming days, and what type of car you will expect to see, how many cars in each type you will have in this car park. If it is a car park in a big supermarket, and then you can also infer what will be your customers. Okay. So let me show you a video. Yeah. Okay. This last.
Where digital transformation is taking place and the world changes in the blink of an eye, Esri users are unlocking the full potential of data to solve real problems in real time. They use location and geography to integrate, analyze, and understand all types of data. They embrace the science of GIS, science that Esri pioneered, and its users continue to advance. Organizations everywhere see data in new ways through a common visual language. Informed, inspired, and empowered by the science of where, pushing the boundaries of geography to create deeper insight and understanding. The science of where is the science of exploration and navigation. The science of the grand and the granular. This is the science of development and the science of sustainability, the science of power and the science of peace, the science of will, the science of wonder, the science of where.
Okay, thank you. Please don't forget the science of where in your research and study.
Thank you very much.
Yes.
I would like to ask your examples. You take a look of the parking lot
Yes.
or the swimming pool.
Yes.
Those are the. Is it in US? The pace?
Yes.
For Hong Kong, the pace is much packed.
Yes.
It may not have the satellite image may not give too much information.
Yeah.
So what can we use? Because those are visualized images and data, but in Hong Kong, how can we use this kind of science of data in Hong Kong?
Actually, for the first example, actually now there is some satellite sensor which offer very high resolution, say QuickBird. They offer the satellite image of 30 centimeter resolution. But certainly you have to buy it. It's not available in public domain. For the second example, this is through by drone, the image. For such small place, they also, even in US, they use drone. So in Hong Kong, you can also use drone to fly the small place as well.
But for example, the car park is indoor, not outdoor. So how can you use those?
If this is indoor car park, you have to use other technology, say CCTV or use sensor to detect if the parking lot is occupied or not. Yeah.
Actually,
Yes.
the same question. I think the real question is how can these technologies help in Hong Kong's situation? So, for example, we don't have so many swimming pools.
Actually, in new territories, you can also, the rating and evaluation department is also thinking to use this technology to detect any property in, certainly, we don't have many people living in houses in urban area, right? But there's still quite a lot of people living in houses in new territories. Yeah. Yeah, so they can still use. Certainly, this is a more US-centric application, but you can still find a lot of, actually, I can quote you a few examples, not necessarily AI, but GIS application in your daily life. Say the KMB, if you ring their hotline, their operator can tell you immediately when you go from point A to point B, which bus route you should take, or which bus route is the cheapest, or which bus route is the quickest. Actually, the operator can't remember so many bus routes, right? They use some GIS to help to answer your query. And I don't know if you have ancestor buried in the cemetery of Wong Hop Set. Now it's the Qingming Festival, right? Wong Hop Set Cemetery is the biggest cemetery in Hong Kong. This is 1 kilometer square. If you go there once or twice a year, you can hardly remember where is the tomb of your ancestor, right? But if you go a wrong route, then you may need to take a long way to go to the correct. But we have helped the food and hygiene department to set up a system which is called cemetery location information system. You can log into the website and type into the name of your ancestor or the tomb number, and then our software can help you to find the best route from the entrance to the tomb of your ancestor.
Did they do IoT on that?
Not yet. Not yet. Yeah.
So actually, I have to say is there some plan to contribute of make the shared training data for the GeoAI, like actually the development of the deep learning for the images. I think the ImageNet is one of the actually big contribute to enhance the algorithm itself. But this GeoAI area is whenever I get the chart, it's not enough to training it. You mentioned one of the difference of the calculation of the image and AI is we want to recognize where, right? So where is the we want to actually recognize the location itself. So what is there is some plan to share of yeah.
Share what?
Share the training data for the GeoAI.
Oh, actually, the training data can be very different for different AI applications. So what we do is provide you a platform and let you to prepare the training data more efficiently. Because the satellite image or the spatial or even the drone image. When you fly a drone, you get a lot, thousands of photos. how can you handle it? So our platform is going to help you to handle this kind of data. Say we can make a very accurate and beautiful photo map from 1,000 of drone images. It will become like 1 image from 1,000 images. Yeah. But unfortunately, in the training process, some human work still necessary. Before the machine can learn how to do it automatically, the human has to do some work first.
Maybe we can take one more quick question.
Yeah, just a quick, maybe a related question about data availability, right? So for instance, in France, there are all these efforts of having open data here and there, but as somebody from academia, sometimes when you try to get that data, there's so much regulation around it. It's very hard to get in the data. I just wanted to get a sense of how the data, social data you work with is available, or...
Yeah, actually, we found that now, because I started my GIS career and research back to 1990s. In that time, we always need to make the digital map data from a paper map using a tablet digitizer. But nowadays, when we tell our client in university, the first lesson they teach their student how to harvest or how to discover the available geospatial data from the web now. Actually, say we
Are
have.
there any repositories that are shared or available?
Yeah, actually, in many countries they have SDI. You can go to the SDI. You can also go to our site we call Living Atlas. We have tens of thousands of data sets contributed by the government, different country government, and our data. Actually, we have a very interesting program called EMU, which is called Ecological Marine Unit. Okay, we divide the ocean of the whole world into many different grids of say certain, I can't remember, certain kilometers square. And then because actually there are lots of scholars or researchers in the world doing a lot of research in the ocean, and every day they take a lot of sample from the ocean. So now we provide them a platform, so when they get a water sample and do the analysis, and then they will contribute their data to the EMU platform. So that we hope that in the near future we can have the whole world data available for different people.
I'm sorry that we are running out of time, but I really appreciate this talk. I see a lot of good response from the audience. Actually, quite lots of questions related about data sources. Maybe after this workshop and this meeting, we could invite Paul to have us compile the pointers, a little file with pointers of where some of these information of these data sets have been located, and that would facilitate our research. Right. Let's give our